Okay, we're just going to take a quick minute here and look at the sine law, the ambiguous case of the sine law specifically. This is something that occurs when we have exactly side-side angle. So this is side 1 here, this is side 2, and this is the angle it follows. So it has to be this kind of a pattern that I'm interested in, the side that touches the next side and the angle that follows. If I have that, I do have kind of a tricky situation that I have to be aware of. So I call it side-side angle. Some people would read it the opposite direction because it's easier to remember. Angle, side, side. Whatever it takes, as long as you recognize it, then we should be in good shape. If we look at this, look at our protractor here, and for some reason it's not, there we go. The measurement on the protractor, you may not be able to see it very clearly, but it's 30 degrees. So I've got this 30-degree angle indicated here. The measurement on this ruler, 10.0, whatever the units are, I've just kind of written it as 100. And this one, 13.5, again, whatever the units are, so 135. Okay, so this is the triangle that I have. I just wanted to have it measured in front of you so you could sort of know for sure I'm not making stuff up. Now the key here is to recognize what can happen. I'm going to clone this, copy it, I guess. One of the things that can happen, given the right set of values here, is that, and I'm going to pull this red line up to sort of show you, first of all, the red line is identical to the flipped blue line. Okay, so the blue line was just the side drawn here that I cloned and repasted, and now the red line is basically the same line. And when I pull this red line over the diagram, you can see that what might occur here is, or what can occur here, is that there's maybe a little uncertainty as to which or where this line lies. This is a 100-unit line. This is a 100-unit line. And in both cases, the information given is the same. I have 100 for my first side, 135 for my second side, and then a subsequent angle of 30 degrees. I have 100 here, 135, and 30 degrees. So if we sort of split them up a little bit more specifically here, you can see the blue triangle here, with the red one kind of faded in the background, is 100, 135, 30. And this one is a 135, 135 and 30, going that direction with the blue faded in the background. Now what's of interest to me is the resulting angle here. Because if I was to do a sine law question, I have this angle and this side, and this is the angle that I would end up finding. So just sort of basic sine law says this angle, sort of sine of this angle divided by 135. Let's call this angle X. And then of course down here, the same problem I guess, would be my angle X here. And if I did just a regular sine law question without really thinking about this, I'm going to be writing that sine X divided by 135 is going to be equal to sine 30 divided by 100. But you recognize right away that this angle and this angle are quite different, and so obviously I need to be able to figure out which one of those is the situation I'm interested in. Now what's interesting here, if I take a look at the, I don't know if I can make this one work or not, but if I take a look at the protractor on the screen, I can see that the angle here, 40, 41, 42, is basically about 42 degrees. So the angle I'm going to calculate in this case would be an angle of 42 degrees. If I were to do the same question, but understanding that this was the diagram down here, then the angle I would want to be able to find is basically just inside of 140 here, 138-ish is basically 138 degrees. And if we look at those two numbers fairly quickly, we should be able to see that they kind of are related in that 138 plus 42 gives us that magic 180 degrees. So basically what happens is when I do my calculation in the sine law, I find this angle. It's only one of the two solutions though. The second solution can be found by subtracting 180 minus the first angle calculated to find the second possibility for that angle, and then I can go ahead and finish the question at that point. So, quick little summary here. We might have the ambiguous case if and only if. IFF means if and only if, so this is a forced case. If we have side-side angle and a situation where side A is less than side B, or what I referred to before as side 1 is less than side 2. Okay, so if we look at our diagram down here, we always label angles and sides that are opposite each other with the same letter. Small letters represent the sides, capital letters represent the angles. So the various possibilities are that we have this side, side A, being too small to reach where we want our line to be. We have the possibility where that line drops perpendicular to the side that we're looking for, and we get a 90-degree angle, and there's exactly one solution. And of course, the solution we just saw where there are two possibilities there as well. So to test it, the first thing is, again, make sure we have a side-side angle situation. Then we test this value times sine of the angle that we know. And depending on what we get, we know that there's either no solution, one solution, or two solutions. So if the answer we get here is still bigger than this side, then there's no solution. If what we get when we do the multiplication is exactly the same as the other side, then we have one solution. And if it's less than, then there are two solutions. Okay, so we'll look at one example here. So we're giving the 36, the 61, and the 30, and we're asked to find the value of x. Knowing that the sine law is what we have to use, there's no right angle in the question as far as I can tell. I don't have a cosine law question. Then I will have to find this angle before I can actually get to the question, which is finding this, finding the value of x. So when I think about it, I do recognize I have a side-side angle situation, which means I need to verify whether first of all, is side A less than side B? And it is. So I have potential ambiguous. I will then test to see what B times sine A is equal to. B times sine A is 30.5. And so my various questions are, is the result from the B sine A greater than A? 30.5 is not greater than A. So that means there is at least one solution. If it's exactly equal to A, which it is not, it would mean that there is exactly one solution. And since B sine A is actually less than A, so again, the 30.5 is less than the 36 that was in the question, it means there are two solutions. And so I can draw in a second side here. There's going to be a second angle here that I'm interested in, and eventually I'm going to come through two full solutions to get here. So I'm asked to find the missing side, and initially I'm just going to use the regular basic question, the x, the angle that was here, and kind of ignore the fact that that was there at all. Oops, sorry. And so find the missing side. Sine of this angle divided by 61 will be equal to sine of this angle divided by the 36. And the question is the same as it would have been in any previous questions. In order to finish up, I do need to know, I eventually need to get here, so I need to know what this angle in here is. I'll call that alpha for now. And so alpha will be 180 degrees minus the 58 degrees, or the 57.9 degrees that we calculated, and minus the 30 degrees we were given, so 92.1 degrees. And then basically x divided by sine of this will be equal to the 36 divided by the sine of the 30. And we can find that it's about 72 meters, feet, whatever the measurement was. So this is the first solution, the red solution. X is 72, given this angle and given the alpha calculated up top. Now our second solution involves this line in here and this angle in here. And so the key, again, recognizing that in order for these two angles to have the same sine value, they must add to 180 degrees. And so if the red angle was 57.9, subtracting from 180, we get 122.1 as the second possibility for that angle. The new alpha value, which now would be just that small angle up in there. In the second case, we subtract the 180 minus the two angles we know, which is 30 and 122. We get 27.9, and then finish up the question in exactly the same way. I guess there isn't one, but the green x, which would be just this length right here, divided by the green alpha, which is this value up here, or sorry, divided by sine of that green alpha, which was the 27.9, is equal to the 36 in here divided by the sine of 30, which is approximately 33.7. Now just one last quick thing. Exact same question here, except I've changed the one side here to 30.15 just to show what you're going to see in that case. So the first question, is there a potential ambiguous case? I have side, side, angle, so there could be. If this is smaller than this, 30.15 is considerably smaller than 61. So yes, we do have the potential ambiguous, and we have to check. So the first question is, when we multiply this value, the other side, by sine of the angle, what do we get? Well, we get 30.5. And then the various questions, is the calculated value greater than the original second side or first side? It is not. Is it the same as the side? It is. And so what that means is I have guaranteed a 90-degree angle at theta. And exactly one solution. Now the interesting thing here, I suppose, is now that I know it's a right angle triangle, I could use the Pythagorean theorem instead of the sine law. I can also use the sine law though, and I'll get that one solution in just a couple of steps.